All right, the number of attendees seems to be stabilizing, so we're going to get started. Welcome, everybody. My name is Mark Coleman, and I'm the marketing chairperson for the CNCF. I'm also joined today by Caitlin Bernard from the CNCF, who's helping out with today's webinar. We're very fortunate to have Aparna and Anthony from Google and Brad from Red Hat, who will be telling us all about what's new in Kubernetes 1.8 today. I'm sure they'll introduce themselves fully as we get into the presentation. Before we get started, I'd like to encourage you to not leave questions until the end. We're going to try and make it interactive as we go through, but you'll notice that you're all muted and you can't do anything about that. So please drop your questions into the chat window and I will find opportune moments to interrupt the speakers to ask them those questions as we go through. That's pretty much it for now. Aparna, are you ready to start?
Yes, I am. Thank you.
Excellent. Take it away.
Great. So we do have three presenters today. I'm going to kick us off with an overview of the features, and then Anthony Ye from Google will talk about graduations and maturation of the Workloads APIs, and then he will also talk about custom resource definitions as part of Kubernetes Extensibility and do a demo for us there. Bradley Childs from Red Hat will take over from there and talk about the storage SIG and the storage features in 1.8, and he will also hopefully run through a demo of some of the new alpha features in storage. So that's essentially our agenda. We can go to the next slide. I'll provide a features overview of the 1.8 release. The 1.8 release of Kubernetes really represents a snapshot of many exciting enhancements and refinements that are underway in the project across the different special interest groups and technologies. The key areas of progress that users should look for in this release include maturing of security features, in particular role-based access controls, or RBAC, and also network policy. And those are two core features, and I'll talk a little bit more about them. Also, there have been changes to move the apps and batch workload objects towards maturity, and Anthony will cover that in more detail. In conjunction with that, we've made huge progress if you're running big data workloads on Kubernetes, particularly in the area of Spark support. And so one of the highlights in this release is that the Spark solution for Kubernetes has been approved for upstream inclusion into the Spark repository. And that's a major advancement that validates that Spark can run successfully on Kubernetes. So we won't go into details on that one here, but we do have links in the blog post to users who want to run Spark on Kubernetes. And then there are a number of notable experimental features. So while security has matured, some of the RBAC and network policy features, and the apps and batch workloads are on their way to maturing, there are a number of alpha features, or what we call experimental features, which we encourage users to start trying out. However, they're not ready for production yet. But there are some exciting ones in scheduling and in storage, and we'll talk more about them, and hopefully Bradley will give us a demo of one of the storage ones. And lastly, it's important to note that there is a deprecation in this release, which is third-party resources, or TPRs. They were deprecated actually in the 1.7 release, but as you upgrade to 1.8, you will no longer be able to use the old TPR definitions. And custom resource definitions, or CRDs, have really matured, and they address a number of the outstanding issues with TPR. So they're a much better mechanism for extending Kubernetes, and we'll give a demo of that in Anthony's section. That's a features overview. Let me go through some of the features in brief before handing it off to Anthony. So role-based access control has moved to stable in this release. RBAC is essentially a mechanism for controlling access to the Kubernetes API, and it went beta in 1.6. And since then, many Kubernetes clusters and provisioning tools and strategies have enabled RBAC by default. Some of our advanced users, of course, were already using RBAC by default because it's such a critical piece of ensuring security and authentication within a Kubernetes cluster. In a nutshell, users are essentially bound to a set of roles, and through those bindings, they have access to certain objects and certain actions. Initially, users start with no permissions, and it is a cluster admin who must grant those permissions. So this is a basic and critical mechanism to being able to use a Kubernetes cluster securely with multiple users. So that's it for this slide. We can go to the next one. Network policy. Network policy has moved to beta. Network policy is also a security feature, and it is essentially a feature for enabling multi-tenancy within your cluster. It's a building block for enabling multi-tenancy. Through network policy, you can specify which groups of pods are allowed to communicate with each other and to other network endpoints. So essentially segregating the network. You can allow or block traffic to your pod through a network policy resource. And it also filters outbound traffic through the policies. So this is important for enforcing security requirements and is found to be critical in many of the enterprise deployments of Kubernetes. It's implemented through a network plugin, and there are many of those that are available. So Calico is a company that provides network policy. This happens to be what we use on Google Container Engine in Google's cloud, but also Weave and Romana provide network policy plugins. And in this particular release, in 1.8, network policy has added support for CIDR and egress-based policies. So that's an additional. And we hope to be able to graduate network policy to stable in the next couple of releases. Next slide, please. Great. Another feature that I'd like to talk about a little bit is Kubeadm. And Kubeadm is a tool that was introduced last year to simplify installation of Kubernetes clusters. It is certainly not the only tool for installing Kubernetes clusters. In fact, there are many, many tools for doing so. However, Kubeadm does aim to provide a set of primitives that can be used by other tools. And so in that sense, it aims to provide a unifying layer for cluster install. The primitives that Kubeadm provides are init and join, so Kubeadm init and Kubeadm join. In the former release, 1.6 and 1.7, Kubeadm added support for the security features, namely RBAC and node authorizers. Node authorizers are a feature that allow you to restrict what the kubelet has access to. In this release, finally, in 1.8, the cluster lifecycle SIG is happy to announce that Kubeadm has announced support for, they've added support for easy upgrades. And so you can upgrade your cluster. So you can obviously set up the cluster, but you can also upgrade the cluster, both the control plane and the nodes, through Kubeadm using the command Kubeadm upgrade apply. And then you basically say what version you'd like to upgrade to. And some of the nice features around the upgrade process are you can run Kubeadm upgrade plan to see which versions are available for upgrade, and you can do you can use the dry run flag for a non-intrusive dry run of the upgrade. That's the main announcement in this release with regard to Kubeadm. There are a couple of alpha features. Self-hosting is an alpha feature. I'm not going to go into that in too much detail. Again, it's experimental. And then Kubeadm join is in beta as before. Thank you. I mentioned that there are a number of experimental features that are quite exciting, and while experimental features are not ready for production, you may be interested in trying them out. So on the scheduling side, priority and preemption has moved to alpha. And this is an important feature for essentially if you want to have some sort of level of assurance with regard to which pods should always be scheduled. And which ones should take priority over others. So, for example, priority and preemption can be used to guarantee scheduling of system pods. So, for example, you don't want the Kubeadm to run out of memory or not have a place to schedule. And so this is an important feature. It's just alpha in this release, but we plan to progress with it and move it forward, and I just wanted to give it a shout out. So that's the overview. With that, I'm going to hand it over to Anthony. And Anthony's going to talk more about if you're running applications, whether they're batch applications or other types of applications, deployments and other objects. What are we doing to graduate those capabilities forward in Kubernetes?
And just before we transition, there's a couple of questions that I'll try and fit in here now. My apologies in advance because I'm going to mispronounce everybody's names, but Uni asks, could you tell us what are the definitions of alpha, beta, and stable in the Kubernetes project?
Yeah, so alpha is really experimental. It's essentially sort of the first installment of a set of functionality that we want users to try out, or we ourselves as a community want to try out. So, for example, we'll talk about snapshots a little bit later, and the priority and preemption feature that I talked about in scheduling. That's an alpha feature. It's not ready for production. It will likely change. The API will almost definitely change. So we don't recommend that folks put that into production. In fact, on Container Engine in Google Cloud, we don't actually offer alpha features for production clusters. Beta is a lot more advanced, and Anthony's going to talk about some of the beta APIs and workloads, and I think those examples will clarify what beta is. And then stable is really, for example, RBAC is where we think that the functionality is complete. It's not going to change. And so it really is production ready.
Excellent, thanks, Aparna. Second question from, and I'm definitely going to mess this up, Thula Siraman, I'm going to go with that. Please tell me if I got it right or not. Asks, is Calico added by default in 1.8?
It is not added by default in 1.8, per my understanding. So I'm sorry if I caused any confusion. We have network policy in 1.8 for Container Engine through Calico, but this is more a presentation about open source Kubernetes, and I don't think Calico is a default in 1.8.
Thank you. That's all the questions for now.
Thank you.
All right, so hello, I'm Anthony Ye. I work on the Kubernetes team at Google. Primarily focused on workloads, which is the things that you use to run your applications, and then also on extensibility. So I'll give a little overview of things that we have introduced in 1.8. And as Aparna mentioned, the big focus this year has been on maturing things to get to GA, general availability, or what we call V1 for each API. The first thing I want to talk about is this apps group, which is what you use for running things that you basically want to be running all the time. It manages your pods, and if the pods go down, it makes new ones and ensures that you have enough to serve what you need. Wanted to talk a little bit about how we do versioning because it can be confusing. This right here is a color-coded chart of all the different ways that you can access deployments and daemon sets and replica sets in just 1.8. And so part of what I want to point out is that these things are in groups called API group versions. So if you look at the first box, that's one group, extensions v1 beta 1, which is the oldest group that these APIs existed in. And what we've been doing is splitting things out of that extensions group and putting them into more specific groups. So these particular controllers, we're moving some of them out of extensions into the apps group to better put them together with peers that have a consistent API and be able to move those along as we create new versions. They'll stay consistent with each other. So in previous versions, we introduced apps v1 beta 1. Now we're in 1.8, we've introduced apps v1 beta 2, which is the second beta of what we hope will become v1. That's how to read that. And then if you look all the way to the right, this is just saying in 1.9, we expect to release apps v1, which will be basically all these same APIs, but in, like Aparna said, kind of the final version of the very stable API that's not going to change after that. Next slide, please. So as part of maturing the API, one of the big focuses for us has been making things stable, preventing errors that don't have to happen if you have a better user experience. One of them, for example, is on all of these workload APIs now, if you use v1 beta 2, the selector is required. It used to be you can forget about the selector totally. We'll fill one in for you in the old versions. But it turned out that that caused more problems than it solved. One of the problems was copying fields from one place to another place during this defaulting phase caused problems with kubectl apply. And another problem was this was encouraging users to never learn about selectors, which had, one, they would be missing out on some of the flexibility that selectors give you, and two, it could cause confusion that would actually cause users to get unexpected behavior. So there's an example of this on the right. Previously, we would, if you don't specify the selector at all, we would just copy all the labels from your pod template and generate a selector that contains all of those labels. But actually, in many cases, you don't want to have all the labels in your selector that you have on the pod. You might have some labels on the pod that will change, and you want those pods to still belong to this deployment. So for example, this one has app label, component label in the selector, but the role label is allowed to change, and these pods will still belong to the deployment. The next thing is the selector now can't be changed after you create the deployment or the stateful set. Originally, we actually never intended for it to be mutable. So it was basically undefined behavior. And not only that, the behavior that did happen was not what most users expected. And so we're kind of coming back to saying, what did we really intend for this? And let's enforce that. So that's part of that change. And then the last thing to point out in apps v1 beta 2 is daemon set and stateful set. In 1.7, we introduced a rolling update. Instead of having to delete pods manually, you can just update the pod template and it will go and roll through update pods for you. But that was off by default in 1.7. What we did now is if you use the v1 beta 2 API, then these rolling updates are on by default in daemon set stateful set, which matches the behavior that you already had for deployment, where it would by default do a rolling update. In addition, for stability, we introduced default revision history limits for all controllers that have history. And what this means is that, for example, with deployment originally, if you keep changing the template, you might end up with an unbounded number of replica sets that build up representing your old history, unless you go in and set this new field that we added in previous versions. Going forward now, we have a default limit of 10, which means you're not going to see that unbounded growth if you are unfamiliar with this setting. Do we have any questions so far?
There was one that came in from Racer. Yeah, they said, what is the split of responsibility between the SIG apps and SIG architecture?
So SIG architecture kind of is an umbrella that ensures consistency across SIGs. And so what we would do is we make our proposals within SIG apps. If there are things that we may not be able to agree on with other SIGs or within our SIGs, then we would go to SIG architecture and say, what is the overarching philosophy that we should be following?
Thank you very much.
All right, and then the second group within workloads that I wanted to talk about is the batch group. So unlike the apps group, which is managing things that you want to run all the time, the batch group is more about things that you want to run. You have a fixed amount of work and you just want to run a pod until it finishes that work and then you're done. So a job will run one instance of this or n instances right now. Cron job is built on top of job. It will create jobs for you at the schedule that you specify in a cron tab type of syntax. And again, we have this concept of these API group versions. So there's 3 versions, and I want to point out there's a little bit of confusion here because the batch v2 alpha 1 is actually the one that's deprecated, and the recommended one now is batch v1 beta 1, which is unexpected. You would think that v2 comes after v1. This is, as you may know, one of the hard problems in computer science is naming things. It turns out that versioning things is a special case of that. So we're working through sort of the philosophy of how we're going to manage these versions in the future. And so this is part of our learning process as we stabilize all these APIs. But just to summarize, batch v1 beta 1 is how you get to the latest cron job. And now that it's beta, what that means is that it's available by default in Kubernetes clusters that are started up with default settings. And then just to go over a couple of the things that we've changed to add stability to these features. In job, for example, in 1.8, we added a feature called back off limit, which is another way, in addition to active deadline seconds that was already there, backoff limit is a new way to specify how many times you want the pod to be retried before you give up on it. This was causing problems before with, for example, a lot of terminated failed pods building up in your system because it was just never going to succeed. And then another thing in cron job, we now have also limits on the history. So cron job goes and creates jobs, similar to the way that deployment creates replica sets. And it used to be that by default, cron job would just keep creating jobs and those jobs would stick around forever. Now there's a default limit on the amount of old jobs that will stick around, so it kind of manages itself and avoids that growth. All right, so now changing topics. This is, I want to talk about how you extend the API in Kubernetes and some of the new things that we have in 1.8. This slide is more about the context. So this stuff is not new in 1.8, but has already been there since 1.7. But what I want to talk about here is the difference between adding your own API server, which you can see on the right, an example of that, versus using custom resource definition. So on the right side, what you have is a custom API server that runs all of the same type of code that our Kube API server, the main API server, is running. But because you have a fork of that code, you can change literally anything in the behavior there as it's responding to requests. And what we do is basically just a reverse proxy. When the client talks to our API server, if it looks like a URL that you've asked to handle, we'll just forward that to you, essentially. The difference with custom resource definition is, as you see inside of, there's these APIs we provide inside of the main API server, like deployment, cron job. Custom resource definition is sort of a meta API where it's an API that lets you ask the API server to host another API for you. So this example shows etcd cluster is installed as a custom resource definition. And what that does is API server is now serving it on your behalf. Now that makes it a lot easier. You just kind of post a declarative definition, but it also makes it a lot less flexible because you have to kind of squeeze all of the behavior that you want into this YAML and say, please do this for me, as opposed to on the right side when you have full flexibility to write any code at all. Do we have another question?
We do have one, yes. Alexi asks, just to clarify, is the job supposed to be created by cron job, or is it more often that cron job should execute its own task?
Should execute. So cron job always does things by creating a job. I don't know if that answers the question. But
we'll find out. Alexi, if that's not the answer to the question. Yes, it does, he says. So thank you. All
right, so hopefully that's a little bit more of an explanation of what custom resource definition is and how it helps you. Now I'm going to talk about what's new in 1.8 for CRD, custom resource definition. One of the biggest things is an alpha feature called JSON schema validation. So as I mentioned, with an API server, if you're writing the whole thing, you can do any code you want for validation. What we're giving you in CRD is a way to specify, as you see on the top right, some simple things like make sure these fields are present, make sure this field is an integer with a valid range within 1 and 10 or something, make sure this one is a string that matches a regular expression. These kinds of declarative things that are simple to express. Because this is alpha, you have to enable it in your API server with the flag called feature gates. You can look at the CRD documentations for exactly what feature gate there. Or if you use the one that just says enable all alpha features, then this will be included. And I'll do a demo of that in a second, but I want to go through the other new things. One of the other ones is garbage collection. So if you look at the bottom right, what we have is an example of a deployment, which goes and creates 2 replica sets, and each replica set then goes and creates pods. And what we've done in the past for these sort of core controllers like deployment is kubectl has to have custom logic to say when you delete the deployment, unless you ask for cascade equals false, if you delete the deployment, it will go and clean up the replica sets for you, which means kubectl has to have custom code that understands how to find the replica sets of a deployment and then how to tell the replica set to clean up its pods and then go back and delete the deployment. Otherwise, we would leave behind all of those child objects. And this approach wasn't going to work for things like custom resources, because we can't go and build in support in kubectl for every different type of resource so it knows how to reach in and clean up the children. So instead what we have is we introduced in the earlier versions server-side cascading delete, which is the ability to have the server take care of this stuff for you, because the server understands the relationships between objects where we declare, for example, that this replica set is owned by that deployment. And then the server will realize, oh, if the deployment that owns it is gone, I'll go and clean up the things that are no longer needed. In the past, though, this didn't work for custom resources. So what's new in 1.8 is that now this works for custom resources, which means instead of a deployment, if you have a custom controller there, this cleanup will work, and I'll show you that as an example in the demo. And then the last thing I want to reiterate is a third-party resource, which was the kind of the alpha version before custom resource definition. Third-party resource is not deprecated; it's totally gone. And what will happen is if you don't migrate before upgrading to 1.8, then those third-party resources will just disappear. So if you go to the docs, there's a guide on how to rewrite your third-party resource as a CRD and how to migrate the data. And there's a helper in the server that will help you with that. So with that, I want to switch over to my demo. And hopefully you can see the console now.
Yes, we can. Thanks.
All right, so what I have here is just a cluster running the latest 1.8.2. And what I'm going to do is install one of my custom controllers that I'm working on. And you can see here, this is just the CRD. But what I've done is added some validation stuff. So this is the full version of that snippet that I pasted in the slide. And so it's just verifying some of these properties and saying some things are required. And I'll show you what that does. So I'm going to install my CRD. And then I'm going to try to create an instance of that CRD. Okay, and then other than this big JSON, which is just spitting back out the object I tried to put in, at the bottom here, you have a list of errors. And the nice thing about this validation now is previously your controller would have to detect, oh, the user specified something invalid, and it will have to asynchronously report that back, and the user has to go and look at, say, the events on the object. This validation for simple things that are, this field is missing, that field should be an integer. You can immediately give feedback to the user and say, go and fix that, and then resubmit it. So what we're seeing here is, let's see, match labels in body is required. Service name must be a host name. So let's see if we can fix those. Match labels. So it turns out what I did here is I put in the old form of selector. What I actually need to do is put in the new form. And without this kind of validation, you might actually, the controller might mistake your selector for being the wrong type and just kind of start silently doing the wrong thing. So this validation is really nice protection. The other problem I had was my service name is not a valid host name. I just fixed that here. And then hopefully now I can create this. And then this custom controller, what it's actually doing is creating pods. Let's see. And what I want to show here is, let's see if I can describe the pod. And you can see things like this is controlled by the custom resource that I created. So that means that the server knows this pod is owned by that controller. Let's see if there's more pods now. Yeah, so there's a few. And then what I should be able to do is if I delete this main controller, if this was in 1.7, what would happen is my controller object would disappear, but all those pods would be left behind. And so hopefully what happens now is after I delete that, the pods should start terminating. And that was because of this server-side garbage collection. I didn't have to write anything in my controller that would do this for me. So with that, it's my demo, and any questions?
Yes, there's another question coming from Alexei. It's a long one, so I'm going to paraphrase a little bit. He asks about the recent DockerCon EU announcement of Kubernetes being included as an orchestration management option. He said, will there be different requirements for creating a cluster? Will it be either A, that you will still need to have at least n etcd nodes, n masters, n nodes, etc., or is there going to be some new way to accommodate, say, 2 or 3 node clusters running in a typical Docker engine style?
So I'm not sure that that is a question that we can cover in this webinar, since it's not related to Kubernetes 1.8. Certainly, I believe that as you look at the Docker Kubernetes capability, custom resource definitions will be something that they may be using, and so you'll be able to see what custom controllers they have there. In that sense, maybe it's related to the topic of this webinar, but I think this specific question we'll have to take it to a different audience.
Yep, that works. All right, thanks, Shapana.
Great, thank you, Anthony. I think hopefully that demo was useful. It shows some of the new capabilities in CRDs, and then just overall, CRDs are an excellent mechanism, and they do replace third-party resources. They're an easier mechanism than Kubeaggregator, so we hope that our advanced users will make use of them. And so at this point, we should switch over to the storage features overview, and Brad Childs from Red Hat will give us that overview, as well as present a short demo.
Hi, everyone. As Aparna said, I'm Brad Childs. I co-lead the storage special interest group in Kubernetes with Saad, who happens to be, I believe, in Italy on PTO today. So I'm going to talk real quick about the Kubernetes 1.8 features for storage that we added this release. I'm going to go over like the stable features, some of the alpha function that we added, and then some of the designs that we worked on as well. For 1.8, it was really a stabilizing release for storage. We had a lot of features introduced in 1.7 that we wanted to make sure were production hard, and that we had all the bugs and kinks worked out of. So we spent a lot of time focusing on making sure that the features we had in 1.7 were correct, and then moving that function to GA. One of those functions, mount options, was something pretty well received. It allows a on-premise storage admin to specify volume-specific properties. So one example of this is NFS. They typically have, when you have on-premise storage, you'll typically have multiple NFS server instances, and each one has special parameters that are customized through mount parameters. So this was really well received when we did alpha, so we moved this to GA in the 1.8 release. Our flex volume is something else that's been well received. We had an update to it in 1.7 where we allowed the driver to be pushed out to running nodes. So prior, you'd have to restart kubelet, bring it down, then bring it back up to get your flex volumes to work. We enhanced the function so you don't actually have to restart kubelet now. We've also added some volume plugin metrics to assist in debugging and performance evaluation. So this is numbers around the attached, detached time and other technical things related to storage, and we had this so we could start providing better benchmark and better testing for some of the individual storage components. Then we also added our retention policy to our already stable storage class feature. And this was to allow a specification of broad retention policy across storage classes. And retention policy is if you want to delete the persistent volume when you release it, you want to reclaim it, or if you want to recycle it. And we've added that to the storage class, where before it was just a PV thing, a persistent volume property. And then we also added fencing support for block devices. And a good example of this, again, is on-prem. We had things like iSCSI that would cause error if it was attached to multiple nodes, and we've beefed up the check for this and some of the support for only allowing iSCSI to be attached to a single node at a time. So this was kind of a bug that people have been stepping on that we fixed in this release. Then we also did some bug fixes and some feature enhancements around local storage. Again, local storage is another on-prem data-intense workload feature that we had in 1.7 that we really went back and made sure that we were doing right and hardened some of the features in 1.8. Next slide, please. Okay, so for our alpha features, we had snapshots and volume resize. This is something that we've been incubating in the external storage repo, and it's outside of the Kubernetes tree. The snapshot function allows users to back up and restore their persistent volumes. So they can have their application running, create a snapshot of it, and then eventually return the PV to that snapshot level or create another PV off of that snapshot. And I'll show a demo of that here in a second as well. And then finally, another feature that we're incubating is volume resize. This allows a user to expand. Resize is a little bit of a trick here because you can't shrink a volume. We've taken out support for that. You can only grow a volume. So we allow users to grow their persistent volumes in size. And this is a beta feature because we didn't have the file system size resize support. We only have cloud provider resize at the current time. But we're continuing to incubate that and, looking at any feedback we get from the community for our next function. Okay, so a lot of the work that we did for 1.8 was design level work. Probably one of the bigger things is the container storage interface, which is a container orchestration agnostic driver layer for storage. It's meant to cross Kubernetes, Mesos, multiple cloud providers with the same storage driver. And this has been a cross-cloud initiative that we've had, and we've really developed the spec for this as part of the CNCF. And then as part of Kubernetes, we've started prototyping the actual proof of concept work and support for this in 1.8. So design and development, or design for CSI and Kubernetes start in 1.8. We should have an alpha feature for that in 1.9. Block storage is another thing that we had a lot of community feedback on, a lot of interest from storage vendors. They wanted raw block storage, whereas right now we have file storage in Kubernetes. So we spent pretty much an entire release talking about the ins and outs and all the different issues around that. Then we had containerized mount, which is another feature that allows us to enhance our end-to-end testing and some of our platform support of storage in Kubernetes. It's not something end user will see much, but it's something there to really help us test and continuously test our storage plugins to make sure we don't have any regressions on them. If there's any questions with that, I'll move to a demo of snapshots.
We did have a question, but it's not really relevant to this section, so we're going to come back to it later.
Okay. So I'm going to be talking over a video of that. We actually had lost some life to the snapshot or the demo gods earlier in the SIG storage call. So I figured we'd just skip to a video here. And this was done by Jing. So let's go ahead and start this. So
Jing is one of the storage engineers at Google. I can get her full name.
Yes, and her and Tomasz have been diligently working on the snapshot feature, and this is the demo of it.
Jing Shu, thank you.
So we're going to create a stateful set with the MySQL server and a MySQL client. Here's the YAML for this. You can see the claim that will get created as part of the stateful set. And then also the MySQL service that's created as well. So I'm going to show all the stateful sets in the system. And we'll see that the MySQL one that we looked at the YAML previously is there and present. And then since it's running, we're going to create a database connection client. and insert a new table and some data into the table, which we will later snapshot and validate that it shows up in the snapshot. So real quick, show the databases and then create a table. So there's our basic table value, which will get duplicated when we create a snapshot. So validation that the data is actually in the table. So let's show the what a snapshot object looks like. And this will be the object you create to actually to cause the snapshot to be taken. We have a persistent volume claim name, and this points to the persistent volume claim that we want to take a snapshot of. And then, of course, the name of the snapshot. Click BI, let's actually create the snapshot by creating a copy of this object. We have a controller running in the background that's watching for these new object creations, and when it sees the new object, it goes and calls the cloud backend to physically take the snapshot. So here's the dump of our snapshot object. And if you look at the message, it's created successfully, and this is coming from the back end and the controller that's watching for these objects. And now we can take the snapshot and either provision another PV from it or potentially roll back the other PV. But for this demo, we'll provision another PV from it and create a second deployment to use that PV in. So let's scroll down here, we'll add our snapshot name to the class, and this will be used to provision the PV next. So instead of creating a new PV from scratch, we'll provision a PV based on the yield snapshot data. And here you see the name of the snapshot. Let's exit from this. So we create the new service. It's going to take a few moments to start up, or the new stateful set. And this is probably the time if I was live demoing it, everything would explode. So it is nice having video sometimes. Okay, so this will complete in a second, and then we will be able to, then we'll want to show the data that was snapshotted in the new stateful set, the new PV. So pod's still running. So even when you have video, it takes a while to do stuff, and who knows, the video could fall apart. I've had worse happen. All right, so here's, so this is done, and we're going to go into our second stateful set and validate that the database table has been replicated with the data. So let's start our table, and then we'll select that value that we created on the old table and show that it's been copied over. So a new demo of the table we created earlier. Here's the tables we created earlier, and now we'll select the value from it to make sure that it copied over when we snapshotted it. We took the snapshot. Cool. And there's the copy of our data. So that really shows you like the end-to-end workflow of a snapshot, how you can back up your data and then use the backup of that data and a duplicate stateful set. And that's all I had for the demo. Is there any other questions?
Thanks for that, Brad. A couple of questions about whether this will be available later, which it will. I'll make sure that that happens. There was one question coming in about MySQL stateful sets that I think Anthony was going to take.
Yes, do you want to do that before the CRD question?
Yeah, which order are we going to do these in? Let's have a look. It's about CRD. Aparna, you're the boss here. Which order are we going?
Anthony, yeah, feel free to take the CRD.
Yeah, I can do the CRD question as well. They kind of tie in actually with the MySQL question.
Great.
The CRD question was, what's a good use case example for CRD, and specifically, does it make sense to sort of replace some things that you might do otherwise with init containers, like setting up MongoDB replica sets or Redis clusters? My answer to that would be init containers are good for getting things initially connected together, but after that, you kind of lose the opportunity to inject logic once everything's in steady state. CRD with a controller is really a way to have logic that consistently runs all the time and is checking membership, reacting to changes when new pods come and go. So I think it's kind of the next level after everything's launched. Now I need to put automation in managing it, and that's where CRD comes in. And then the other question I think is related, which is for MySQL, the question was, why would you want to run MySQL in Kubernetes, basically with stateful set or whatever, instead of just running it in individual VMs or on bare metal? And my answer to that is the benefit comes when you make use of all of the automation features that Kubernetes provides in order to, so one of the problems that they mentioned in this question is, let's say there's node failures and then you try to bring things back up and you have problems with making things rejoin together. And so this is the place where Kubernetes can provide a lot of places for you to insert your logic and glue to make all that stuff happen automatically. So actually there should be nothing for you to do when this occurs. It should kind of self-heal itself. This is all sort of still in early stages in terms of for each particular application like MySQL. But what we're doing with things like these API extensibility efforts is laying the groundwork so that people who are experts in MySQL, I used to do a lot with it at YouTube, can go and write these automation that will use the Kubernetes APIs to make all this stuff fit together. And one thing I'd like to point out is there's an example of the end state of like what happens after you go through this process of automating every possible distributed failure in MySQL. It's a project that I worked on before called Vitess, VITESS, and we actually put some work into making that run on Kubernetes very analogously to the way that we run it in Google at YouTube. So take a look at that if you're interested in MySQL and you're using Kubernetes. It does a lot of this automation stuff for you.
That's great. Thanks, Anthony. There was one other. Aparna, do you want to jump into questions now, or are there any more slides?
Yes, let's go into the questions. So there's a question on the features in how many are alpha, beta, and stable. I can take that one. It's a little bit arbitrary what a feature is. So many small changes tend to be features. Therefore, we don't always pay that much heed to the number of features. But if you're interested, there's about 40 features in this release total, 4 of which are stable. So the stable features, we talked about RBAC, that has moved to stable. We talked about support for volume options, that's moved to stable. Also support for higher level metrics for volume metrics, that's also stable. And then there's a new security feature at the container level, which is to allow privilege escalation. And that's been added to security context. So that's a stable feature. But again, some of these are smaller changes, and so that's why we don't necessarily pay that much attention to the count of features. As far as beta and alpha, roughly half are beta of the remaining, roughly half are beta and half are alpha. We went through several of the beta features, again, just in terms of the categories. Custom resource definitions are beta. Workload controllers, we went into detail, those are beta. Cron jobs is beta. There's a number of other beta. Network policy has 2 beta features with CIDR support and egress support. And then there's a number of features related to the horizontal pod autoscaler that have also moved to beta with regard to arbitrary or custom metrics usage. And then Kubeadm, the upgrade command, we covered that. That is beta. The exposing storage usage metrics is beta. Kubelet client rotation is beta. Anyway, I would refer you to our release notes for more details on all of the features, the full list, and which are beta and which are alpha. On alpha, we talked to several of the alpha features. We spoke to again, there's a longer list, but priority preemption, volume snapshots, we gave a demo of that. And then there's also persistent volume resizing. But again, alpha work is alpha work, and it's many times incomplete. And so I think it's less interesting to sort of dig too deep into the alpha.
There was a question that just came in from Alexei. First one is there any UI available for the RBAC features at the moment that would help people to be able to manage those roles? I guess that would be within Kubernetes or from anywhere else.
I am not sure that there's additional support for RBAC in the UI in the Kubernetes dashboard. I can check. Not that I'm aware of, but I can check.
Great. And the last one, again from Alexei, is do you recommend any of the cluster init tools like Kubespray, Kops, or Terraform?
I don't think that we have a recommendation. Different tools have different areas of strength. I think SIG cluster lifecycle themselves would not recommend a particular tool. KOps kind of covers not only cluster installation, but also cluster provisioning. Kubespray is a newer tool, so it has some of the more modern methodologies. It uses some of the primitives from Kubeadm. Kubeadm, again, as I mentioned, intends to be the sort of reusable modular piece that can go into KOps and can go into Kubespray. But at the moment, there are many different ways of deploying a Kubernetes cluster, and that is something that SIG Cluster Lifecycle is actively working to consolidate and to standardize.
Thanks, Aparna. Right, we're almost at the top of the hour, and there are no more questions coming in right now, so I think we should wrap it up here. Thank you to everyone who attended and for all the questions that you put in there. Of course, a huge thank you to Anthony, Aparna, and Brad for explaining all the exciting new features in 1.8. This is the first time we've done one of these webinars, but I've enjoyed it, so I hope we're going to be doing one for 1.9 and everything that comes after that. Also, a big thank you to Caitlin, who has been quietly making sure that everything runs smoothly in the background. That's all for now. Thank you very much, and I hope to see you again sometime in the future. Bye-bye.